there. We're going to take a look at a second order differential equation, and I'm going to kind of break it down. What I find in these problems is sometimes the algebra of simplifying the solution is the hardest part. So let's jump right in. So when we have a second order differential, we want to start by doing some substitutions. We're going to use the properties of the e to the x and its derivative. So I'm going to let y be e to the rx. That means that y prime will be r e to the rx, and y double prime will be r squared e to the rx. Now, let's make those substitutions in our equation. So in place of y double prime, I'm going to put r squared e to the rx. In place of y prime, I'm going to put r e to the rx. And in place of y, I'll put e to the rx. So now I'm going to factor out an e to the rx, since they all have it. And we know that e to the rx, e to any power, is never going to equal 0. So really, I'm solving this r squared minus 4r plus 11 equals 0. That doesn't factor. Man, don't we wish it would. So we're going to have to use the quadratic formula. So I'm going to put those values in. Negative b plus or minus square root of b squared minus 4ac all over 2a. So I get 4 plus or minus 16 minus 44 is going to give me negative 28. And that's going to be a complex solution because we have the I under there. So I've got 4 plus or minus 2i if I take the square root of 4 out. And then I've got a square root of 7 left, all divided by 2. So it looks like r is going to be 2 plus or minus I on the square root of 7. Okay, so now let's put it in our general form of our solution. And so that's going to be y equals constant 1 e to the r1x, so the first one. So we'll do 2 plus I square root of 7x. And then I've got plus the second constant, e to the 2 minus I square root of 7 times x. Okay, and this is where I find that it gets to be a little bit, we got to really do some simplifying, really use some of our exponent properties, and then we're going to use a formula too. So first of all, we know that when we add exponents, we were multiplying them. So I'm going to break these apart into what they were before we added those exponents. So we'd have 2 to the e to the 2x times e to the I square root of 7x. Okay, and then I would have the same thing over here. I would have e to the 2x and then times e to the negative I square root of 7x. Okay, now obviously you can see that they both have an e to the second. And I apologize if you're like, I know how to do that, I can do that all in one step. For me, when I worked through this problem, it was very important that I kind of wrote it all down because I got lost a little bit in the simplifying and I wanted to make sure I got all of the details. Okay. So next, when we have complex solutions, then we're going to use the formula that e to the ix is equal to cosine of x plus I sine of x. Okay, so what I'm going to do is I'm going to use this property for this e, and I'm going to use it for there as well. Okay, so what that looks like is y equals e to the 2x on the outside. I've still got c1. And now I'm going to put in here, x is actually going to be square root of 7x. Because I have to have I times whatever is being multiplied. So this is going to be cosine of square root of 7x plus I sine of square root of 7x. Okay, now I've got the other one, right? So this time I've got C2, and this time I've got I times negative square root of 7x. So that would give me cosine of negative square root of 7x plus I sine of negative square root of 7x. Making sure I'm getting all my parentheses in there. Okay, now at this point, I need to use some other trig properties. So one thing we know is that cosine is an even function. And that means that it absorbs any negatives. So that negative right there actually gets absorbed by the cosine. We know specifically, and let me write it over here, that cosine of negative theta would be equal to cosine of theta. Okay, now sine, on the other hand, is odd. And that means that sine of negative theta equals negative sine of theta. So we're going to make that adjustment in our next step. I'm also going to distribute their constants, their coefficients in this case. Okay, so I've got y equals e to the 2x. I've got c1 cosine of 7x plus c1 I sine of square root of 7x. Oops, I forgot my square root on that cosine. Okay, now here, this is where I'm going to distribute the C2, but I'm going to absorb that negative as well. So I've got C2 cosine of square root of 7x. And then I've got minus, because that negative is going to come out front, I got minus C2 I sine of square root of 7x. Okay, so I made two changes there. I distributed the coefficients, the constants, and I also adjusted these using the trig identities. Okay, now what I want to do is pull the cosines together, pull the sines together. So I've got C1 cosine of square root of 7x plus C2 cosine of square root of 7x. And then I've got C1I sine of square root of 7x minus C2I sine of square root of 7x. Okay, now one thing that I want you to notice, and I'm going to do this in kind of an intermediate step, is I really could write this as C1 plus C2 cosine of square root of 7x. And this one I really could write as C1 minus C2 I sine of square root of 7x. Okay, I really could simplify like that. I'd still have my e to the x out here, e to the 2x. Now, here's the important part to recognize. When you add a constant to a constant, you get another constant. Okay? When you take a constant, you subtract a constant, and you multiply it by I, you get another number, right? You just get another number. So we actually can simplify this down to y equals e to the 2x times a constant, and I just labeled it 1. You could do 3 or 4 or whatever number of constant you want. It just has to, this constant has to be different than this one. That's the only difference. C1 cosine square root of 7x plus C2 sine square root of 7x. Okay, so remember, we're saying C1 plus C2 is a constant. We're saying C1 minus C2 times I is a constant. And that's how I simplify it. Now, friends, the calculus part of this was way up here. Okay. We used a little trig here, but this is just all some algebra and simplifying. And then look at where the bulk of the problem is. So that's probably where you want to focus your time and attention on really using some of those simplifying strategies. I hope that helps. If you need some other help, feel free to leave me a comment below. Bye for now.